Again, wonder here. Do common factor. Okay. No additional questions on that. To come back in time. This is what we did before Christmas. These are notes from before Christmas. So we've done this last part before. Okay, but we're kind of throwing this all together. This last section, that 35 to 43, this last section is this right here, solving quadratics. Okay, and there's two types, two ways that we solve quadratics. The first one is if there was not a linear term. We use what we call the square root property. So if there's not an x in there, so if it looks like a difference of squares sort of thing, you can solve for the x squared, take the square root of both sides, you add that plus or minus. Remember using that plus or minus? Okay, so you still get your two answers. You can write it out x1 equals positive 6, x2 equals negative 6 if you want to. Okay, so you can go back. These should be in your notes. This is what we took. The second way is when you have a linear term, you had to set it equal to 0. Then you're going to factor it. And once you got your factors, this is where we set the factor equal to 0. So the factor is x plus 4. I want to find out what is the 0 for that factor. So x plus 4 equals 0, or x minus 9 equals 0. That comes from there. So if I solve for x, I get x1 equals negative 4, x2 equals 9. So notice these questions now, these questions 34 to 43, the answers will look like what we started with here. You're finding these numbers. So when they ask you to solve an equation, and it's a quadratic, you should have two answers, or it could be a double root. Okay, so these questions here, we're taking the roots and coming up with the equations. These are the equations, and now you have to come up with the roots, working at both directions. Okay, we'll do a few together. Okay, sounds good. Alright. Let's start with this one. X squared minus 3x minus 28 equals 0. And notice this says solve now. This is an area on the final. These questions weren't our strongest by any means, so doing some more. Okay, we'll get some more practice. So, is there a linear term? So is there something that just has the x on it? Yes. Okay. So you see that with the 3x? Okay. So that means we have to factor it. So factoring, the first step is always look for the GCF. So is there a greatest common factor? No. There's not. There's 3 terms. There's not 4. So we're not going to do the grouping. So we're going to go straight to our factoring method. So we need 2 numbers that multiply to what?
Negative 28.
Negative 28. The hesitancy there is telling me we're not comfortable with this yet. And it adds to negative 3. See where those numbers are coming from. Juan? Sure? Okay, Nate? Okay. Bethany? Cassandra? Sure? Okay. You good? Okay, so what 2 numbers are they? 7 and 4. Again, the more you do these, keep looking for shortcuts that happen throughout this process. Plus 4x minus 28 equals 0. So we split the middle. This is what we were doing yesterday. So Lon, this is what you're doing on those 26s and 27s.
We don't like the right, but we don't like we
Correct.
don't equal to zero.
Correct. Because you're just factoring, you're not solving. Okay. So take an x out of that, x minus 7, take a 4 out of that. So you get x plus 4 times x minus 7 equals 0. Is that process okay? Did you get to this last step by yourself? Okay, that's whether you know it's okay or not. If you were basically with me ahead of me, or if you're just copying down what I say, then you may not be quite there yet, which is okay. We keep practicing it. Okay, so now to solve, when they want you to solve, you have to do this extra step. These are the factors. So you have to say x plus 4, where does that equal 0? X minus 7, where does that equal 0? So you get your first x to be negative 4, you get your second x to be positive 7. So maybe look through your work, see if you notice a trend or anything that might help you get your answer. Okay. So where would this graph cross the x-axis? Hang on to your question. Negative 4 and 7. What are the roots? What are the zeros? What are the solutions? What are the x-intercepts? Negative 4 and 7. Okay, yeah.
So, like, since those are just the opposite of the M and A, would that just be, or those just be the roots opposite of those? Or is that
Not all the time. In this situation, yes. In this situation, yes. So, your hint there, Kale, is when there's a 1 there, then it's just going to be like that. Okay? So if there's a 1 in front, you notice these two numbers are the same numbers that show up here, negative 7 and positive 4. So then those are your factors, then your roots or your zeros become negative 4, positive 7. So from 2 days ago, we had a note that said the roots and the factors are opposite numbers. So if these are your roots, or if these are your factors, then your roots would be opposite. Now if you start putting numbers in front of here, we'll do that next. It won't be like that. Round and factored. Let's just do that. 16x squared minus 16x equals negative 3. 16x squared minus 16x equals negative 3. Eddie? No question. Yep, I want you to start on it. So, yep. So is there a linear term? So this one, if there's a linear term, you have to move it, everything to the left-hand side. You want it equal to 0. Because that's where you equal the x-intercept, is when you equal 0. Okay? So it should be plus 3 equals 0. Okay. So now, any common factor?
Nope.
3 doesn't go into 16 evenly, 2 doesn't go into 3 evenly. Those are factors, but it's not a factor that's going to make things easier for us. So, no. Okay. So here, two numbers that multiply to what? 48. 48? 16 times 3? And they have to add to 16. Good. That's better. So a positive and a negative number. Two negatives. Yeah, sorry. Two negatives. does exist. 6 and 8, that'd be negative 14.
Yeah.
So not 6 and 8. Yes. So if 6 and 8 is the only one you can think of, then you can break like 8 down. 8 is 2 and 4. So if 4 goes into 8, then 4 is going to go into 48 as well. Okay, so negative 4, negative 12. No, 4 and 12 will not be the answers in this case. Okay, because we have a number 16 up here. If this was a 1, then it would be. Okay. Okay, group those two. When they say solve and there's that equal 0, I like to keep that equal 0 with me all the way down, because that reminds me that I'm solving this, I'm not just factoring it. Okay? That way you don't just get to the end and write your factors and you don't solve it. So depending on how you write your negative 4, negative 12, that affects what numbers you take out of each parenthesis. Okay.
Do we actually put a decimal, or can we just do a fraction?
Do a fraction. Now, 3/4. 3/4 is a nice decimal. If you put 0.75, that is okay. If it's something that you have to round, then you have to put the fraction. So. So 3/4 and 1/4. 0.25 and 0.75, that'd be okay as well. See the process there? You see what we were doing yesterday, and then this is the only thing that's new on this last part. Okay? Now I'll tell you, there is a way you can use these numbers to get these. Okay? Tell you in advanced math.
Figure out first.
It has to deal with that, since the fact that there's a number there, it has to deal with that first number. You have to do something with that first number. Eddie?
What do you have to do if there's more than one variable square and stuff? Like on
And,
Oh.
no, and then
32. Now 32 you're just factoring, you're not solving.
Yeah.
So what I'll do on 32 is always look for a greatest common factor first.
So 4.
4 and look at the variables.
No,
Z squared. So you can take out a 4z squared. And you notice that's going to take away the z squared part of that problem. It's going to take it to the front. Okay. You figured it out?
Does it have to be negative? Is it like
Nah, positive 4z.
4 is 1/4 of 16 and 12 is 3/4 of 16?
You just divide by 16.
but do you have to then flip it because it's negative?
Yeah, because remember these are your factors. These are not your zeros.
Oh yeah.